Last section deals with modeling with functions, basically just writing functions depending on what you have. It's really just a fancy way of saying that you're doing word problems. With that, I already have number 1 and number 4 on there as far as a video. So we can still do those, or we can do different ones. So it's completely up to you as far as, like, second hour I wanted 1 and 4. We talked about 2 a little bit in 1, but there's not a video of it. So, so then if we look at 2, the biggest thing is making sure that you know what it's asking and what you're trying to find. So on 2 it says on a certain route, an airline carries 6,000 passengers per month. So let's just say from Kansas City to St. Louis, 6,000 people a month, and each of them are paying $200 basically a trip. So market survey indicates that for each $1 that they increase the plane ticket, they're going to lose 100 passengers in the month. So it says express the number of passengers per month as a function of the ticket prices X. So we're going to deal with, so basically what we want to happen is, like, X is going to be the ticket, or the ticket price rather. So, sorry. So think about it this way, that the ticket price is your X value, of whatever you have. How would you write, like, the ticket increase? Well, but it's $200 originally, right?
Yeah.
So how would you know, like, if I would say, so not really X plus 1 or X plus whatever, how are you going to figure out how much the price went up if the original cost is 200?
200X.
But you want to know how much the price went up. So, like, say if it was $273, how much did the price go up? How do you know that? Because what did you actually do, though? Right. So you took X minus the 200 that was the original. Does that make sense?
So it'd be like it's X minus 200 equals N. No.
Well, hold on. Okay. So your ticket is X number of dollars. The ticket increase would be however much your new ticket price is, minus the 200 as far as what your original value is. Okay? So from there, then what about what's going to happen in the decrease of, let's think about it this way, people taking the flight? How would we write that? So what's going to happen every time they raise it $1? What's going to happen? So basically, if it's every time they increase the price, what's going to happen? Minus 100 for every $1 that they go up, right? So then, basically, what it's going to be $100 for every X minus 200 that we have. Because if it goes up to $201, how many people are they going to lose? $100 or 100 people. Not $100, excuse me. If it goes up to $205 instead of the $200, they're going to lose 500 people, right? Does that make sense? So that 100 right here is for every $1 that it goes up. So every time X is more than the 200, whatever that is, whatever value you want to call it, we're going to take that value and multiply it by 100. So then if we are going to write the function, how much, if we're going to write it as n of x. How much are they starting with? How many people are they starting with? So we're going to write the function in terms of the number of people per the ticket price. So what are we going to do with, we're going to use this part right here, but what else do we need? How many people do we start with per month? Per month, excuse me. 6,000. So it's going to be 6,000, right? That's how many people you have, minus what happens if the price goes up. Okay? That 6,000 we're going to take away from that. Does that make sense? So that's where the part in red is going to go x minus 200. So depending on, obviously, depending on what you have. Now, I'm okay with you leaving it like this. I'm okay with you leaving it basically here and calling it good. And that's probably a little bit more realistic than if you saw it as, like if I actually distributed the 100 into everything and had 6,000 minus 100x plus 20,000 and doing it that way. All right. I would probably leave it like this. I'm not sure as far as if you would have this type of problem, if it would want it like in the parenthesis. I think this is easier. I think what's in the box is easier for students to understand because they get, okay, if the ticket price is $225, I'm going to take 225 minus the 200, and then I'm going to multiply that with the 100 and go that route. Whereas what I guess we saw was something as far as, or the way that I guess the book really sets it up, is that n of x is equal to 26,000 minus 100 times x. Okay, so whatever your ticket price is, and went that route. Okay, the book's going to put it more like this. I would say for your all's sake, you're probably going to be more apt to understand everything this way. You agree with that? Okay. Just, there's really, we have what, like, I think what's in blue sets up better for part B because it's going to be easier to multiply. Because if it's the value, so it just tells us that, what are we going to do? So if it's r of x, so it's just basically a new function. Okay, so it's a new function for r of x, but really we're just going to use what we had in part A. Where if you used what's in the yellow, that's fine, but it's not going to work out to be nice and neat. Because what ultimately are you going to do? With either this part or this part, what do we need to multiply that by? What does it say, right? It says the product of the number of passengers and the ticket price is their revenue. So how do we write the revenue? What are we going to do with either what's in the blue box or the red box with, what are we going to multiply that by? What's the ticket price? What variable did we use for the ticket price? No, that's the increase.
Oh, yeah.
So the ticket price is just x. Right? So in terms, if you can basically take it one of two ways, and you could either write it as, take the 6,000, if you would leave it like this and have 6,000 minus 100 times x minus 200. And then multiplying it by x, that's the same thing. Or if you want to keep it as one kind of simple equation, is taking the 26,000 minus 100x and multiplying it by x. The one down here in blue or blue-green, whatever color down here, is going to be a little bit easier to, if you want to write one long equation and just take your 26,000 x minus 100 x squared to know what they're actually going to make as far as the revenue, and kind of to see how much revenue do they lose? Do they lose money? Do they gain money? That sort of thing.
At
So-
a certain point where they are making the exact same as they used to, even if they were.
One thing I would make sure you have is like the surface area of kind of your three-dimensional objects. So the surface area of a cube, surface area of a rectangular solid, cylinder, and then a sphere.